Good morning, AP class. How are you doing? This is our second lesson out of the 4 we need to do, and it is called direction fields, or I actually call them slope fields. There's a subtle difference between the two, and I'll tell you what they are. Also notice as n numerical methods. There's a method called Euler's method that's used to approximate these answers that we're not going to bother with. Our objectives are to draw direction fields or slope fields for a given first order differential equation and to draw a solution curve to a first order differential equation. I'd like you to work on the worksheet I sent you or that I've included in the folder. The book problems are not so good, but they're fair. I just didn't like the way they looked. The one I'm giving you is something I've used for years and years and years and years, and it's not something of my creation. Something I took. So you'll see there's somebody else's name on top. You can thank her for her hard work. Today on these notes, we are going to actually do problems 1, 3, 7, 8, 9, and 10 all together. I want you to do up to 16, the rest of them, on the worksheet. There are questions 17 and 18 that we will do in the next section. So let's get right to it. What is a direction field? Well, you see by this wind map of the eastern part of the country, it's the direction that wind is blowing. So, for example, you start with something here and you just follow the arrows. This is the way the wind will blow it. And you can obviously tell the weather trends. And here, if you see something like this, looks like it's a nice, easy weather pattern across the country. Nothing too crazy going on. You start down here, you kind of follow these arrows, kind of get pushed down and maybe come back up a little bit. So a direction field just tells you which direction to go, and the basic application for it is a wind map. Wind maps are used to tell crazy phenomenon weather, something like this. Look at this wind map right here, where all of a sudden you have a swirling wind and all of a sudden it shoots in, and then all this craziness happens. All here is insane. Who knows what's going on? But that is the pattern you get when you have a cell storm. So it's one application for a direction field. But notice there's little arrows on here so we know which direction it's going. Hence the name direction field. We'll be doing slope fields. And slope fields are going to tell us which way our function is going. But functions can go left and right, so there's no arrow on it. Let me give you an example. We have dy dx equals x plus 1. It's a first order differential equation because it has the first derivative in it. And this is actually something that we could solve. We could take the antiderivative of this because really dy dx is just y prime, isn't it? So if we did y prime equals x plus 1, and I asked you to tell me what the antiderivative was, well, the antiderivative of x would be x squared over 2. The antiderivative of 1 would be x. And we don't know where it starts, so we call it plus c. So in this particular case, it's a parabola. Well, let's see what a direction field will show us. A direction field should show us by graphing the slopes of what this equation should look like. We're going to graph the slopes. Now, it has an infinite number of slopes, depending on which point we choose, because there's an infinite number of points on the graph. So we are just going to choose a few and get an idea of where it's going. Now in this case, we have x plus 1. So I'm going to make a little table of an x and its slope. So if you think about that, what I'm asking you is if we pick a value for x, and we have -3, -2, -1, 0, 1, 2, and 3. So let's say we pick -3. If I put x into this equation, -3 plus 1 is -2. So this basically says wherever x equals -3, the slope is -2. Wherever x is -2, the slope is -1. Wherever x is -1, the slope is 0. Wherever x is 0, the slope is 1. Wherever x is 1, the slope is 2. 2. We're adding 1 to it. When you have x of 2, then the slope is 3. When you have x is 3, the slope is 4. So what I'm going to do is graph these slopes. Now I'm going to graph these slopes with little tiny lines, and we'll start with the easy one. Let's start with this one. At x equals -1, this original function has a slope of 0. So here's -1. All these values where x equals -1. I'm going to draw little tiny lines that have a slope of 0. This is a slope field. I'm not going to put arrows on. I'm not going to tell you which direction to go. I just know it's going to be flat right there. Okay. What about this next one? Another easy one might be this one. When x is 0, y has a slope of 1. So this is where x equals 0. So I'm going to draw slopes of 1. When x equals -2, we have a slope of -1. And then what happens as we go out to either side? The slopes actually get steeper. When x is -3, the slope is -2. So all these have slopes of -2. Now these aren't necessarily easy to draw in the sense that how do you know the slope is exactly -2, exactly -1? You don't. These are generalizations for us. I'm going to show you a computer program that will do it for you much more accurately. But on the AP test, typically in the past, they would give you either questions about an already completed direction or slope field, or they would give you a slope field to fill out with only a few points. And the most I've ever seen is 6 points to fill out. But notice here when x is 1, slope is 2. So these slopes are going to be getting more and more steep. This will be a slope of 3. And this will be a slope of 4. So I did the best I could. It's okay. But notice, if I take a point and I start it here, this is going to go up. It's going to come down. It's going to flatten out here. Then it's going to go back up. And what does that look like to you? A parabola? I would hope so. Like I said, the plus c value, I don't know where the parabola starts. So if we started, say, here, we're going up like that, down like that. A parabola. Okay? The c value anchors us along this line. That is a slope field. That was a easy slope field in the sense of it was easier to graph. Now I'm going to do one where it's not as easy to graph because the slope actually involves x and y value added together. So we can't just say when x equals something, then the slope equals something because x and y are together. Here's basically what I mean. We have our x value and our y value and our slope. Okay? All right. We're not going to do every point because we're going to notice patterns. It's always our goal is to find patterns. Start with a nice easy one. The point 0, 0. So right smack dab in the origin of the graph. Well, 0 and 0 is x and y. The slope is going to be x plus y. Well, 0 plus 0 equals 0. So right here it has a slope of 0. Now, do you see anything else that would also have a slope of 0? If you had -1, 1, isn't -1 plus 1 equal to 0? Wouldn't anywhere on the graph where x and y are opposites have a slope of 0? So this is -2, 2. You add those up, you get a slope of 0. 1, -1, a slope of 0. So notice how this fits a pattern. Unlike that fit a pattern that was straight up the x values. This is a pattern that would be diagonal. Let's see if that worked for the next one. So let's pick this point here. So this point here is 1, 0. So if I pick 1, 0, the slope, 1 plus 0 is 1. So this has a slope of 1. So will this work here? Well, this point here is 0, 1. Well, guess what? 0 plus 1 is 1. This has a slope of 1. So along this diagonal, these all have slopes of 1. Well, what about this diagonal, where we start out with 2, 0? Well, 2, 0 is 2. So this has a slope of 2. And so will this. That's a terrible slope of 2. Let me try that again. So this has a slope of 2. And so will all these, which means these would have a slope of 3. These would have a slope of 4, and these would have a slope of 5. So I'm really sorry about those bad slopes. But you can kind of see how this goes. It's going to be shooting up this way, shooting up this way, shooting up this way. What happens on the other side of this? Well, what happens right here? And we'll go down. What about here? What about 0, negative 1? Well, 0 plus negative 1 is negative 1. This has a slope of negative 1. All along this diagonal pattern, we have a slope of negative 1. Well, that's interesting. If it's coming out this direction, it's going to like just go that way. Well, what happens over here? So we'll go 0, negative 2. Well, 0 plus negative 2 is negative 2. So we're going to have a slope of negative 2. Which would mean, consequently, this would have a slope of negative 3. These would have a slope of negative 4. This would have a slope of negative 5. Notice if you have something that starts here, it's going to go down that way. But if you have something that starts here, it's going to flatten out and shoot up that way. So it's interesting what this equation would look like. We've never done an equation, have we, with a slant like that before? So we will have a lesson where we will actually solve this differential equation and come up with a solution for it. But right now, this is what the graph would look like. It would look like something like this. Now you might think that's a little bit weird, that's crazy. And you know what, it is. So I will provide you a link to the Desmos website, because the Desmos website has this. It actually has a slope field generator. All you have to do is come in here and type out your differential equation. The first one we did was x plus 1. Boom, there it was. Notice that this point right here, if you can see at the end, it's hard to tell against the cursor, it's got little tiny lines that tell you the direction it's going. So right here, the slopes would be that, And notice how the slopes flatten out to 0, and they go like that. So isn't that what we did in ours? I believe that's exactly what we had, something like that. This one here was x plus y. Let's see what we get when we put it on here. Instead of x plus 1, we'll do x plus y. And sure enough, look at that. So if we have a point that starts out here, it's just going to shoot up and shoot up and shoot up. Okay, so this will draw any slope field you want. If you want it to be 2x divided by y, that's a slope field. Look at that crazy thing. So what, these go up, and if you're over here, it kind of shoots down and goes up. So this generates the slope fields for you automatically, so you can get a good visualization of what's going on. So I will make sure that you get that link. That's basically what we're talking about. I'm going to ask you to do a few on your own, but this is a typical question you would get on a test when it was multiple choice, is they would give you a choice of slope fields here, and you would have to figure out which equation goes with what. So you can kind of think about, well, what would this graph look like? So if I took a point, this is going to shoot down. This is going to come up. Oh, this is going to look like a parabola. This is going to go up and then down and then up and then down. What does that look like to you? To me, that looks like this. This looks very much like a sine curve. So this is number 7. Now how do I tell the rest? So if you look at, I usually pick a point. Like pick a point like 0, 0. In 0, 0, the slope here is 0. In 0, 0, the slope here is 0. 0, 0, the slope here is not 0. So which one of these, the remaining ones, would not give us 0 at the point 0, 0? Well, if x and y are 0, 0 minus 0 is 0. If y is 0, 2 minus y is 2 minus y is 2. So at 0, 0, you have a slope of 2. That looks pretty good. We'll call that number 9. All right, this pattern right here. Well, if you recognize it, it's one we already did. But notice how when x is 0, the slope is 0. When x is 1, the slope looks like it could be 1. The slopes are increasing as the x gets larger. And only the x is being affected. And notice here, like the one we had done previously, we had that slant to it. Well, because x's and y's are being subtracted. So we know that 0 minus 0 is 0, and 1 minus 1 is 0. 2 minus 2 is 0. 3 minus 3 is 0. So this is number 8, and this is number 10. So that's just using your knowledge, your skill, and your awesomeness to figure out which equation goes with which slope field. So what I'd like you to do is the worksheet that I sent you is do up to question number 16, and you're going to notice we've already done a few of them, so you don't have to repeat them. So you do not have to do number 1, number 3, number 7, number 8, number 9, or number 10. And then don't do the last two, 17 or 18. We're going to do that in the next section. So this will be the last thing I can send you before spring break. So I hope you guys have a great break. I mean, being at home. And let me know if you have any questions whatsoever. I'm going to spend the break getting ready for our last two sections. We'll be done with what we need to get done by the first week after break. So by the end of April 13th, we'll be ready to go. And then after that, we're going to have an assessment on this, and then we'll talk about what we're going to do to review for the test, or just review in general to put all these concepts together. So I hope you guys have a great day and a great night, and I will see you at another time.